I guess at this point I'd like to open up the floor for questions and answers, if anybody has any. There are microphones to the left of me and to the right aisle.
Hi, my name is Peter.
Yep.
It does seem like there's a blurring. It seems like there's a push more to have the designers take on the load. There's a concern there. I see a lot of benefit where the verification does separate that line, and it almost seems like the effort that could be put in could be more on the system architect level, where basically these formal properties and assertions are basically another way to describe the spec. So having the designer to, sign off to provide some of these properties and formal, assertions, and make that part of a deliverable as lint is. Now the designer has to provide linting, they have to provide the properties and whatnot. It can be kind of skewed. So the designers, at that level still miss some of the system level or some of their block design properties. Just as Mr. Goodenough was saying about they're sitting in a meeting and all of a sudden I didn't think about that. The system level architects, as they're describing the space or the interaction or the system level, or even sometimes some interfaces are not fully implemented. They're lights, not fully implemented. So it seems like a lot more energy could be going into the mindset of how system architects convey this spec. There could be more work done to impose that they're talking in terms of properties and formal. Now we have these tools that sort of cheat. They provide all these properties after the fact a little bit.
So are we asking too much of the designers to run all of these tools and provide all of these assertions, or should we have them spec it up front? Anyone?
I do not believe that you can spec a design entirely up front. No. There are certainly aspects, certain bus standards that are well understood, but really the spec itself is evolving too. I mean, it's an exercise in design. In fact, one of the problems with having an entirely formal spec is that you limit the degrees of freedom in which somebody can go implement this. Anyway, I'm not a big believer it's possible.
So formal properties are one way of doing it. Maybe this area has to grow to be a little bit more, accepted. Or there's a push in verification to grow in term. I mean, look at UVM. It's moved way to the point of object-oriented, and design now has, they're so resistant on assertions and properties. They want to speak in RTL. So there's some benefit to imposing a little bit of that.
I do believe that it is possible to write a spec that is actionable and clearly defining use cases, helping the consumer of that spec, which is the verification team. I do believe that is possible, yes.
So what I think is happening as a positive trend is that all these tools that the designer is able to run up front, they are narrowing the part of the system on which the designer is obligated to convey a spec to the verification engineer. So basically a lot of the implementation concerns are being abstracted out from the verification people, and the verification people are getting to focus on the bigger system level issues. And I think that is a very positive thing in terms of productivity for the designers too.
And timing is also a concern, because you have, now if you have the designers providing that, when they hand off the block, obviously all that's working. So you have to have a higher level sign off. So this spec is now conveyed, and so you don't have all these properties working in the beginning, because you're just verifying that it's not done. So you have to have a sign off, and so verification's job is to say, here's what the system architects have said that we need in terms of formal properties, and also a collaboration with the designer's formal properties. And now the sign off is, have we turned all these on? Have we turned these on? So
in my initial questionnaire of you guys, I asked an interesting question. I asked, should we be hiring more superstars, or should we be hiring more average people? And I was pretty shocked by the answers that you gave. To a man, almost all of you said we need to populate with average people. maybe have one expert out of 10.
No, I didn't say average. I said I need
John
a
definitely
team
did
of
not say that.
superstars.
So I know ARM and Cavium are both just hiring superstars, and that's all we want to populate our team with. But you guys have opposite opinions in some way.
I don't think it's opposite. I want smart people, right?
Yeah.
I want smart people, but I want repeatable processes. In other words, I can hire superstars, and I can't necessarily repeat the success. And it particularly becomes problematic when one of my superstars leaves. You know, I want smart people with repeatable processes.
Yeah, I agree. That's actually the challenge. The challenge is you want superstars, but that also brings you people management. The people management of a team of superstars is hard.
Yes.
So I think only superstars, but obviously they have to be team players as well. But yeah, I also go for superstars.
Well, we're asking these designers to do a lot more than they used to traditionally do. Not only do they have to write super specs, they have to write great RTL with assertions, they have to run all these different tools. These are kind of, we're asking quite a bit from the designers at this point, are we not? Mm-hmm. How do we get by in an extremely large team? At Intel, you almost only have average engineers. So how do you guys get by?
No, I object. No, so as I said, I think we're looking for superstars. They have to be team players. The teams are big. The teams and every team has to be both the consumer of other teams' products, and in many cases also basically a provider of his product to other teams. So, like you said, I mean, you can't handle all those aspects of design and verification and other things that designers have to understand. You got to be very good. So team player, I think it's a very important quality, and yes, people have to be very good.
Do we have any more questions? JL?
So I guess designers complain a lot, I think, that they have to do a lot of these different technologies. So it sounds a little bit like nobody ever complains a lot about all the things that verification engineers have to do.
Well, the verification engineers complain plenty.
What I'm wondering is, it seems like the designers maybe aren't quite up to the task, and maybe they need to. How do we get these designers who are really not up to the task of doing all the things that the verification engineers can do? How do we get them in the right mindset to be able to do the work that they should have been doing in the first place?
Oh, first of all, I disagree. I am not seeing that. In fact, Wally shared some of the data on this. We saw a transition within the past 2 years where design engineers are spending more of their time in verification than design. So I'm not convinced that we have to convince them. I think it's happening.
The level of engineers that you get when you're doing an SOC is generally very high. I mean, the issue between the superstars and the average Indian is not his level of intelligence or her level of intelligence or his capability of learning tools. It's more a personality issue. The superstars generally are a little unfocused, let's say, and hard to manage, and you need some around to help lead the ideas of the group. But as far as the functioning of the group, these guys are capable. I mean, we were just talking about the salaries in the Valley right now. I mean, they're making good money to do what they do. Of course, they have no life. That's another problem with design engineers. But they can handle the load. There's no absence of capability either on either side of the team anymore. I mean, the days when the verification guy was the guy that couldn't handle design is long over.
Do you think that it's just a mindset issue? I mean, is there or is there not a mindset issue? I mean, it sounded like from Brian's question there might be a mindset issue. Well, it may not actually be that hard.
Well, I feel it's like my definition of a superstar is somebody who's already been doing this for several years.
Yeah. By the way, an example of a superstar that exists nearly everywhere in the industry is the analog guy. Yeah. They are a superstar. Yeah. They lack processes.
Oh yeah.
And you lose that guy, man, you're in trouble.
So the
Well,
role of
those
the-
guys are hard to find, too.
Yeah.
That you can't really hire 150 of them off the bat.
You don't want to.
So the goal and the role of EDA tools is to sort of to marginalize the need for superstars, if you will, and to make the processes more predictable. And I think the trend is in that direction. Of course, there's some aspect of creativity involved in the design as well as the verification side of things. But you want to keep that to as narrow a space as possible.
And another comment about the tools, and it goes back to this discussion about where Formal could use and other tools that are not just simulations. If you can define the task very well, and a tool or an environment will basically check for that area, provide very good feedbacks and debug capability, then it becomes something that could scale.
Let's try to get another question.
Yeah, so we are fortunate that lately we have a number of good technologies and tools in our bags, right? However, despite, I just would like to hear from the panel that what kind of bugs we are still finding from the chips, based on your experience. Thanks.
What kind of bugs are still being found?
There are many bugs. There will be, in the SOC you have, again, IP is coming from different sources. So although the IP will be typically, verified at the IP level to all kind of scenarios and configurations, it's very hard for the IP designer, the design team, to capture everything that may happen in the integrated environment. So a lot of our issues, at least at the SOC level, would be what happens between different IPs and what happens when that IP talks to the main buses and things like that. The other aspect is the software hardware, which we mentioned before, that the IP doesn't really have any, in most cases, any notion of what's going to happen in the software of the SOC that will happen, in a year time frame. So that, happens later, and, one of the efforts is to bring it in and make it, much earlier.
Another question on the right.
Gordon from Mentor. I'm a reformed designer. I'd like to ask the panel to make a prediction. I think there's a few aspects to this dilemma. There's the technological aspect, which we've discussed, and the peopleware aspect, but it may also be driven by economics in the future. We've had a technological era the last 15 years. We've made advances, and we've created this wall that Gary described between design and verification. In 10 years' time, do you think that wall will have been broken down by the kinds of techniques we're talking about, hardening designs, instrumenting, or do you think the wall will be reinforced and verification will be a tool provider to the design teams?
Broken down.
There always will be skills that are required. For example, someone putting together a UVM testament, you're not going to get a designer to do that, right? So there are certain skills, like some of the point John was talking about, where you do architectural formal. It takes a significant amount of skills to go do that. So not everybody's going to be doing everything, but I think this we have to, and we are breaking down these walls between design verification too.